Hi there, the Pragmatic Luthier back again. Um, Yesterday I put out a video on making your own barrel nuts, and I had a system that's basically built on this block. If you haven't seen it, take a look at it. Um, but I woke up in the middle of the night somehow thinking about this, and I came up with an easier way to do this, and I'm excited to show you this. So I'm going to bring the camera in here, get you closer, and show you what I've got going. Just a quick review before I proceed. If you have not watched the previous demonstration in this series, you may want to take a look. This is what I showed everybody how to make yesterday. Um, this works, but it does take a lot of fussy measuring and fussing around that maybe you don't really need to do. This is the system that I use to make my 3/8 barrel nuts. Um, but this is very precise and very durable. But of course, this requires the use of a metal lathe, and it uses a milling machine to actually do the drilling and even some of the preparation work. So we need something that doesn't require any of that junk. All of this came about, by the way, I'm sure you know this, but I'll remind you, because I needed a 5/16 diameter uh, barrel nut. And not having that readily available near me, I said I'm going to make them. Well, here's what you can do. If you need to make a special one, a particular diameter, here's a really simple way to do this. I just took a block of softwood and I used my table saw to cut a groove in the center of it. And the depth of that groove only needs to be a little more than half of the diameter, thickness of the barrel nut that you want to make. You can see how that sets in there, but the nut sits up above it a little bit, a third of its own diameter, maybe a quarter. I don't think it needs to be too fussy. You want a snug fit. You don't want it to be able to slop back and forth, but you don't want to have to push it down in so that you can't get it back out without a lot of leverage. Now, I also, in my center cut, you can probably see how it's a little deeper in the center. I don't know if that's necessary or not, but it seemed as though it might cradle that piece of steel rod a little bit nicer. So that's what I did. Easy enough to do. The next thing I did was just at random somewhere on that, I made a mark that's going to show me where to drill, and then I made a mark to show me the end of the barrel nut. So I'll just slip this in there, and I match up the end of the rod that I'm using, and there's the distance to the drill point. That way I can register what I'm doing every time I want to do this. And I'm presupposing that I am not going to cut these to length first, of course. I'm going to slip a rod in there and position it, do my drilling, and then pull it out and cut it off to length. That seems to be the easiest way to do this, I think. Well, this works very nicely. I put a cleat across this so that, excuse me, turn this around. I put a cleat across this so that I can just screw this thing down tight. And that's what's going to keep the rod from rotating out of position when I drill through it. And I made that little cleat, I did make out of a pretty stiff hardwood. You want something strong, I think. And I thought, well, maybe you could use a piece of metal, but I didn't use metal because my concern is that the metal would eventually bend uh, over the bar and remain that way. And then the second time you use it, you wouldn't get the pressure that you need. So I went with a piece of wood, and that does seem to work very nicely. If you were to do this and this is not holding well, then maybe you'd want to recut this block and make that groove a little bit shallower. And I think it's also important, I used a nice pan head screw on that so that it's got good force down on it without chewing down into the wood. Now, the beauty of this is that if all of this were to just go to hell on you, you can remake the whole thing in just minutes. It's just so simple to do. And now I want to show you how to drill through this thing. because you've got to hit dead center. And it looks like it might be a problem, but it's not too much of a problem. I'm going to show you the coolest trick. I'm just going to register this where it belongs in advance and tighten down. And then I'm going to take you to the drill press and show you the neatest way that you can drill through the center of that. And by the way, you see I have this mounted on a larger block. This was the length of the material that I had, and I was even going to cut it shorter, which you could, but I screwed the thing down to this larger, nice flat board because I want to clamp this tight to my drill press table, and this just gave me something longer that I'm more easily going to be able to get clamps on. So what we need to do right now is find the absolute top dead center of that cylinder, which isn't as hard as you might think, even if you don't have precise measuring equipment. Now I started by putting a drill or a point of some kind in there, like this, and I just eyeballed the mark where I want to drill. And you can eyeball that so precisely you're gonna hit it. So that is up and down the length of the rod, you're centered where you want to be. But now across the rod, we have no idea. And I eyeballed that center across the diameter of the rod, but that's not good enough. And I've clamped the rear end of this to the drill press table, and that's so that I can move this front end in tiny increments without losing position all over the place. Now, to find the top dead center of that isn't that tough. I'll start with a Slick Exotic first. If you have one of these, and if you have one of these, you know what it is, and you probably have already thought of doing this. This is, for those who may not know, this is an edge finder on this end and a center finder on this end. And these things are designed so that you can hit an edge, and this cylinder part that moves will, as soon as it hits an object, it will run concentric, and then you can use the point to get where you want to be, or the other end. These are very nice, and they're dead accurate. And even if you don't spin them to get them to run concentric, I learned a couple of years ago online that you can, just with your fingers, even with my fingers that are calloused and chopped up, you can feel concentricity within, far less than 1,000th of an inch. So if you have one of these, you're really good to go. But I want to do low tech because a lot of folks may not have this. Well, I took a piece of steel rod. It doesn't need to be hard steel. And if it is hardened, you're not going to be able to do this because it's been tempered. But I took a piece of stock. I chucked it up. This is 1/4 inch, by the way. I put this in my drill press, and I used a file underneath here to just file a point in that. Now, that can be inherently inaccurate, I suppose, but I found that if I go very carefully with my file, try and keep a steady stroke across there, that you can see when that point is properly formed, because the bottom edge of that bevel will be nicely balanced, I guess you might say, even all the way around it. And of course, the test of accuracy would be to put it in your drill press and spin it at a drilling speed. Pardon my hands in the way there. By spinning that at a drilling speed, as long as that point runs concentric, and you can see that easily, as long as that point is concentric in its rotation, then it's accurate enough for what you're doing here. Might not be accurate enough for making 8-cylinder engines, but we're not doing that. All right, so now, how do I find that center? Can you eyeball it? No, I wouldn't trust that. But here's the neatest thing that you can do. You take any 6-inch scale, not too heavy. I wouldn't use the 6-inch blade out of a combination square, although I suppose maybe you could, but I haven't tried it. But I have two very lightweight and another 6-inch scale. This is just so easy. I'm going to move the camera so that you can see right into the end of this. Get a good look at this. Pardon me for the adjustments here. Okay, I hope you can see this all right. Now, and I have to be able to see this too, so my hand or my head's going to be in your way here every once in a while. What I'm going to do is set that scale over that rod, and I'm going to bring my point down to touch it. And you see how that scale immediately moves. Well, if that scale is not level, then I'm not over the center. So being that it's tilted that way, it means my point is on that side. So I'm going to nudge this slightly, and I'm going to touch again. Went too far. And as you can see, this is a little fussy. Now it's going to take you a minute. And by the way, don't point on any of the increments or any of the printing. That's going to invalidate your results there. Want to get a clean spot. All right. So I'm just going to adjust slightly and keep trying that. And what you'll find is that as soon as that rule comes up level across there, which you can see, and you don't want a lot of pressure. You're not trying to drive the point down into that. You just touch it down there to make contact. And as soon as that scale is level across there, you're over the center. And you would be amazed at how accurate that actually is. You could do a lot of fussy measuring and probably not be any closer without the use of a machinist XY table, say on a mill or something. So I'm happy enough right there with what I've got, at least from the angle I could see it. I'd be better off to get right down in there, but I think we've got it. So now, to make sure that we're not going anywhere, I'm just going to clamp this down. And there I've got it. I'm in position and ready to drill. So now, referring back to yesterday's previous video on this, I'm ready to put my lettered drill in, which yesterday the requirement was for a number 25 drill, I believe. So I'm going to, whoops, excuse me. I left out a step. Super, super important. Since I have no guide hole, I don't have a bushing to guide my drill. I forgot this. We need to take care of this. We need to center drill first. Now, if you're not familiar with center drills, this is a large one. This one, I don't remember what the number is. At any rate, this is a center drill. And they come in many different sizes. This is large compared to what you can get. They get really tiny. But the purpose of a center drill is to start a hole. And a center drill, unlike a regular twist drill, is machined in such a way that besides its length giving it more rigidity, its point is machined in such a way that when it touches down, it will drop and drive straight down, where a drill point will skip and move away, especially on a cylinder. It would be practically impossible to drill this without a center drill. So I guess there's the kicker. If you don't have one of these, you'll need one. The upside is these are not expensive at all. And even if you're just doing mostly woodwork, boy, these things come in really handy sometimes. Now I'm ready to center drill, but to give myself just a little bit of a leg up, I'm going to take a file and as carefully as I can file a facet across there. Very, very tiny. And you are taking a bit of a risk here because if that facet isn't nicely at right angles to the center line of the drill, it may cause your drill to drift a little bit. Now, I started doing that with this larger file. If this is what you have, I'm sure you could do that. But if you have some needle files, you can just make that facet a little bit smaller. and it doesn't need to be large at all. You know, just wide enough for that center drill to get it to grip. So now I'm going to chuck up my center drill and give it a shot. Here we go. Very carefully. And all I need is that dimple that you may or may not be able to see in there. So, and I'm also going to look at that and ask myself, I'm going to look carefully and see, does it appear to be on center well enough? And it's looking good from my perspective now, so I'm going to continue on to drill my hole. All right, I'm all chucked up with my appropriate drill, and we're going to drill. Now, I'm going to use cutting oil on this regardless, because these are really good drills. As I mentioned, any oil is better than no oil, but a cutting oil for this sort of thing is better. All right, I went and turned off the light. There we go. Watch out for this stuff here. It can be sharp. And it looks like we've done the job correctly. Well, here we are, drilling completed. I'm not going to re-demonstrate tapping because that was in yesterday's video. I don't think we need to repeat that, but just showing you what our results are here. Now, this hole, there's a burr on the opposite side of that, so getting that out of there might be just a slight challenge, but we got it. You can see there's a burr on that side, and you're going to want to take a deburring tool or a file or something and get that off there, because if not, it's just going to make threading it more difficult, and it will make inserting it into the neck tenon difficult as well. So at any rate, there you have it. It looks like I hit center pretty well with that. I'm very happy with it. And now you can cut it off and finish it up just as you would as demonstrated in the other videos. Well, I want to thank you for watching this video demonstration. I got sort of excited about this particular technique and this device because it was so much simpler to make than this. This took quite a long time, an hour or more. This took less than 15 minutes. So easy enough, right? I just want to repeat, however, that the reason these demonstrations came about is because I have a need for this special size barrel nut, which is not readily available to me locally, you know, within reasonable reach. And I don't care to order a bunch of these from a supplier at some distance or through Amazon, because I'd rather make them, and I can make them. I can't imagine anybody would want to go through the task of making these tools and doing this work for something that you can run down to the store and buy. That's certainly understandable. But it's a reminder to anybody who's building guitars or anything else, whenever that special need comes up, if you can find a way to make your own tools to accomplish your task, then you've got a leg up. And there's a lot to be learned in the doing. Anyway, I'm Kevin Ledoux, the Pragmatic Luthier. Still, the last I checked, the largest guitar manufacturer in the entire town of Triangle, New York. Population, I think 2,900 and something. At any rate, thanks again for watching. Look forward to another upcoming video related to these, but not on how to make them. Thanks again for watching.